So at the top of 489, you have this shaded box. It is the same idea, defining what a radian. The central angle of 1 radian is subtended by an arc with length r. So whenever, again, the picture that we could draw here, if this length along here if the arc length cut out by an angle is the same as the radius, that's 1 radian. And we already found out that that is a little bit less than 60 degrees, or 57.3 degrees. What this opens up for us now is all of the math that you've ever done with degrees up till now is now redone with radians. And we're going to practice all of that math again, but now we're going to write all of our answers in radians, which is just another measurement. Just like a very common thing that people have different measurements for here. How many people know their height in feet and inches? How many people know their height in centimeters? Okay? And so depending where you're from, we have different measurements, right? So how tall are you? 1 meter 77, okay, or 177 centimeters. How tall are you? 5'5"? So Lorenzo's 177, Sherelle is 5.5. Wow, he must be a giant compared to her. If we don't use units, 177 seems a lot bigger than 5, right? You're 5.5 or whatever. But the units are important. So we need to be able to convert so that we can talk about the same thing. Either you have to find out how tall you're in centimeters, or you have to find out how tall you're in feet and inches. And then it's going to be easier to compare. They're just two measurements of the same thing in a different way. So some important things here. It's really easy to remember what the whole circle is. 360 degrees to you by now with degrees seems like common sense because you've used it so much. We now need to make 2 pi radians common sense for you. And again, right here, I wrote the circumference formula to tell you that's where it comes from. It comes from the circumference formula. Now, with that, if you know that 360 degrees is 2 pi radians, it's really easy to figure out that pi radians is 180 degrees. What did I do? I just divided them both in half. If I want to figure out what 1 radian is, I can take this, pi radians equals 180, and divide both sides by pi. On the left side, that would give me 1 radian. On the right side, it gives me 180 over pi. I'm going to put a purple box around that. Because this, if you can get this purple box, you can now change any number of radians quickly to any number of degrees. Also easy to find. Draw it like this to this arrow. Write it up here. If you wanted to find out what 1 degree was, can you take 180 degrees and divide it by 180? That's pretty easy. I do the same thing on the other side. Pi divided by 180, and I find out that 1 degree is pi over 180. And now you can convert any number of degrees easily to radians. If you know 1 degree is pi over 180, then 10 degrees would be 10 pi over 180. And 100 degrees would be 100 pi over 180. So you can easily convert that way as well. Now what we did in 6.2 is we figured out arc length formulas. But because we did it when we just knew degrees, so far we have only made a formula for degrees. The arc length formula on your formula sheet, they use the letter S. Because there's no S in the word arc, I'm not sure why. Not sure why the letter S for arc length. But the formula that we came up with in degrees is we said, take whatever angle and make it out of 360 because that's the proportion of the circumference that you have. This formula is not on your formula sheet. On your formula sheet, you have the formula for radians. The radian formula looks like this. Still have the S. Well, it's still a proportion. If you had an angle in radians, you would still be asking, what proportion of the whole thing do I have? So I'm still going to have theta out of, but instead of out of 360 degrees, if I'm dealing in radians, I'll have theta out of 2 pi, because that's how many radians are in a circle. And then that's the portion of the circumference that I have. Now, even though I really, 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 really like this formula in this method because it looks identical to the other formula that we made, and it makes sense as a proportion of the circumference, at this point, mathematicians cannot resist simplifying. The simplifying is just so obvious and so easy. Can you see that the 2's would cancel out and the pi's would cancel out? Because this is like a fraction over 1. And the formula is just the angle times the radius is your arc length, which makes sense. And I think this should make sense. Here's a circle. Let's say they tell you the angle is 2 radians. What does that mean on the outside for my arc length? I would have 1 radius here, 1 radius here. I would have 2 radiuses around the outside for my arc length. If my angle was 1.5, I would have 1.5 radiuses around the outside. And so the very first formula on your formula sheet, before the sine squared plus cos squared equals 1, is your arc length formula in radians. And you don't get the formula in degrees, although I think after we did 6.2, it's really easy to figure that formula out. So now with this idea of radians, and we have a connection between radians and degrees, we can go to our first question. And we have an angle of 170 degrees. We want to find its measure in radians. So in A, what we're doing is we're changing from degrees to radians. We want to figure out what 170 degrees is. Some of you are going to be able and just have the fact that you know that 1 degree is equal to pi over 180 radians. Some of you will have that memorized. Others of you will go, I don't want to memorize that. I just want to figure it out. It doesn't take me very long. Okay? Because I know that 2 pi radians is 360 degrees, I know that 180 degrees is pi radians, and I can just divide by 180 to get 1 degree by itself. So for some of you, you will just use logic to refigure this out. Others of you, after figuring it out a couple of times, will just have it memorized. But if you know that 1 degree is pi over 180, if you had 170 degrees, does it make sense that you would have 170 of these pi over 180s in radians? And so to change from 1 degree to 170, I multiply by 170. I'll do the same thing on this side. I'll multiply by 170. And I'll get 170 pi over 180 in radians. You could type that into your calculator. That's the exact measure, so we call this exact. If we went to our calculator to figure out what this is, 170 pi divided by 180, 2.97. That would be to the nearest hundredth. Part B, okay. Part B says to sketch negative 12 pi over 11 radians. And it also says to convert, to change from radians to degrees. Again, some of you will memorize the fact that 1 radian is 180 over pi degrees. For others, you will figure it out. You will say, I know that 180 degrees is pi radians. If I divide both sides by pi, I get 1 radian is 180 over pi. Then if I want to change and figure out what negative 12 pi over 11 radians is, I would need to take 1. What would I multiply 1 by to get negative 12 pi over 11? This is why 1 is so nice to have. It's like, I could multiply 1 by negative 12 pi over 11 to get negative 12 pi over 11. If I do that on this side, I need to do that on this side as well. Of course, something really nice happens with the pi's. They cancel out. 12 times 180, 2160. That would be an exact answer if I divided it by 11. Negative 196 degrees is probably easier for you to visualize. Can you visualize negative 196 degrees? So the reason I didn't sketch first is because right now, most of you will have a better chance sketching if you think of the degrees than you will think of the radians. Negative 196 degrees is a little bit more than 180, so it goes past 180 degrees. It'll end in quadrant 2, negative 196 degrees. But we will start to think about radians and be able to do this directly. If a whole circle is 2 pi, 180 degrees is pi radians. That's halfway around. Can you see that negative 12 pi over 11 is the same as negative 1 and 11th pi? Change that improper fraction to a mixed fraction. So I'm going 1 and 11th pi's. 1 is like 180 degrees, and then 1/11th more. Imagine this top part being split up into 11 equal sections. And you need to just go 1/11th more. Part C is another one that's saying change from radians to degrees. So here again, you're going to use the formula that 1 radian is 180 over pi degrees. Another thing that you can do to help you remember this, if you say to yourself, well, I know that 1 radian was like that 57 degrees, just a little bit less than 60. 180 divided by 3 is 60. 180 divided by a little bit more than 3 will be a little bit less than 60. That might also help you remember this formula. If I want to find 7.5 radians, what would I have to multiply by? 7.5. So I would need to do the same thing on this side. If I wanted to leave this as an exact answer, 7.5 times 180 and sometimes questions will say, write an exact answer. But if I want to have a real good feeling of what this number is, I would go to my calculator and say, what is 1350 divided by pi? 429.7 degrees. I probably didn't round to how they asked. Oh, nearest 10th. I did it. Yes. Again, notice you do a question, then you reread it because they probably have some finicky thing about how many decimal places you need. So questions for practice. 4, 5, and 7.